Here we go. 5.6. Graphs of other trig functions, part 2. So we're going to graph tangent and cotangent. Now, these are kind of the odd ducklings in the group because they're not following any of the patterns per se of sine and cosine, especially secant and cosecant. So let's see what they look like. Try a bunch of different colors here today. All right. So a couple tables here. So let's look at a table with tangent. Okay, and we're going to see what's happening to its values as we're plugging x's in. And then we'll do the same thing with cotangent. And the goal is to pick up some behaviors of it, okay? And underneath it, let's do this. We know tangent can be written as sine over cosine, so I'm just going to put that in parentheses. We can use that to help us out. And cotangent is the reciprocal of that. So I'll put that in parentheses as well, just so we can use that to evaluate some things. I'm going to go just the first quadrant with this. So let's do, give me some full space. 0, pi over 6, pi over 4, pi over 3, and then pi over 2. I'll repeat down here as well. Okay. And what I'm doing is, to figure this out, I'm going to use the unit circle. Okay. So I'm going to plug those in and see what we get. So 0 of tangent is just 0, okay? And think about why that's the case. Sine over cosine. Well, I know sine of 0 is 0, so it doesn't matter what cosine is, it's just the whole thing becomes 0. Pi over 6, that's square root of 3 over 3, but let me write the decimal underneath it. So it's approximately 0.58. Again, I'm using the decimal to see what's the behavior of the function. Pi over 4 is 1. This is square root of 3, which is approximately 1.73. And then this guy becomes undefined. Now let's think about why that's the case. So pi over 2 corresponds to the point 0.01. And we know that, sine is the y value, cosine is the x value. It would be 1 over 0, so no good. So immediately, that's triggering me to say that is going to be an asymptote for us. Okay, specifically a vertical asymptote, obviously. Okay, now below, if it's the reciprocal, we're just flipping some values here. So this is now going to be undefined. And again, that's telling me this will be a vertical asymptote. This is, hey, that was good. Trick shot. There we go. Okay, next, pi over 6 would be our square root of 3, which is roughly 1.73. 1, this is square root of 3 over 3, which is just 0.58 again, and then that one's 0. Okay? All right. Now, let's decipher this a little bit. A couple things to know. So 0, tangent 0. But right after 0, I can see my values increasing, right? So it is increasing. Bless you. So I'll put that underneath here. So it's increasing. But at this spot, it's done, right? So if that's the asymptote, then can we imagine it's increasing? It's going to keep going infinitely upwards, but not crossing that vertical line, okay? Now, on the other side, if I were to go negative pi over 6, negative pi over 4 on this side, these values are going to repeat, but they're just going to be negatives, right? Does that make sense? So what's happening on the left-hand side is that instead of increasing to the asymptote, it's going to be decreasing to the asymptote on that side, which would be negative pi over 2, okay? So I kind of have a visual for what's happening here. And here's the cool part. So here's 0. Here's my two asymptotes. So I can see that increasing without bound up to here, and then the other side, because it's negative, it's going to be decreasing without bound. This kind of looks like a cubic in a way, doesn't it? Remember cubic graphs from Algebra 2, or from Algebra 2 and college algebra. So that's going to be the general shape, and we're going to graph the full thing out, but just kind of give us an idea of what that is. Okay, now cotangents are reciprocal, so we can imagine that it's going to behave like this, but what? Kind of like the opposite in a way. So if I look at it, it starts at undefined, but look at my values. As it goes to 0, it is decreasing. Are all my markers dead? There we go. Decreasing. Okay? Now if I were to continue this, all right, again, it's going to be the opposite, so it's actually going to be what? Increasing, right? Going to its vertical asymptote. So just for a general shape of it, so this will be my VA this time. Over here, well, we'll get to it, but pi would be my vertical asymptote for it. Okay? So we're going to have a point here where it's at 0, so it'll be pi over 2, and then it's going to be doing something like this. Okay? So it's going to be going in the opposite direction. Again, I'm going to graph it fully and go from there, but there's the general shape for it. Okay? So any questions on just looking at the table and kind of analyzing what it's going to look like? So again, not quite like sine, cosine, and cosecant and secant. It's its own little thing, which is cool. Alrighty. So, a couple things, just to write some facts down. So for tangent, we will have VAs, so vertical asymptotes, where cosine of x is 0. Okay? And the reason why I state that is just like what I did over there. If I look at the quotient identity for tangent, yeah, cosine's at the bottom, so if it's 0, it's definitely undefined. So that would be a vertical asymptote. So thus, pi over 2 and 3 pi over 2, our graph will not cross. Okay? But it will cross when sine is 0, okay? So sine's in the numerator here. So anywhere, if I plug any of these values for sine and get 0 for the whole thing, it's hitting the x-axis there. So let's write that down as well. The graph will cross the x-axis where sine of x is 0, okay? So we'll say that these points will be at x is 0, pi, we could say negative pi, and so forth, okay? Just kind of keep going in that direction. Now I'm going to go ahead and do the same thing. So I described the table using this. Now I'm going to do the same thing for cotangent. So on the very bottom here, let's put for cotangent, we will have vertical asymptotes where sine of x is 0. Okay, so the complete opposite of what we just described in the first paragraph. Thus, at 0 and pi, for instance, our graph will not cross. Okay, but we could say that the graph will cross the x-axis where cosine of x is 0. So for example, these points will be at pi over 2 and like negative pi over 2, and just kind of following the same pattern, anywhere we see cosine to be 0. Okay, so we're looking at multiples of that every pi. Okay? It always seems overkill, like, I mean, we can kind of gather from the tables that I have to write in words, not necessarily, but I mean, a good math notebook, if you can go back in your math notebook like a couple months from now and you can understand what you did, then you did a good job writing notes, okay? All right, so let me go ahead and put the graphs over here. So let's let y equal tangent of x. Okay. Yeah, I'm gonna jump ahead. So we have pi over 2, pi, 3 pi over 2 and 2 pi. I'll do the same thing on the left-hand side, just with negatives. Notice that, and this kind of did the same thing with secant and cosecant, the amplitude didn't really affect the graph that much. If anything, it tells you if it's going to rise faster or it's going to be wider, right? Horizontal stretch, or not horizontal stretch, vertical compression. So if there's a number out in front, that's all it's doing is just changing that part of the graph. Okay, so we kind of, again, I kind of showed you over there what's happening. So at 0, tangent is 0. Let me use a different color. Where's that red one? Okay, there we go. Really? I don't like that. Oh, that's better. That's much better. Oh, it doesn't want to erase. Oh well. So we're going to go with it. Okay, so our asymptotes, if you take a look, so we pi over 2, okay, negative pi over 2. And just kind of go with the general shape of it. We know it's going to be increasing as it gets closer to pi over 2, but never crossing it. And in the other direction, it's just doing the opposite. It'll be decreasing, but not ever crossing the negative pi over 2. Now, here's the interesting part when it comes to this. From here to here, this is one cycle, one period. That's all you'd be graphing. That's it. Okay, if you remember from a prior lesson, tangent and cotangent, like their periods are just pi. They repeat every pi length. Unlike sine and cosine, they repeat every 2 pi. So their graphs are a little bit longer, but that's it. That's just one cycle. But I'm going to show you multiple cycles, okay? It's just following the same pattern. So 3 pi over 2 would be another VA. Pi is when it's 0, and then it's just modeling the same behavior. So this would be 2 periods or 2 cycles. And if I want to end at 2 pi, it would look like this, but it wouldn't go past it if I'm ending at 2 pi. And on the other side, following the same pattern, there's my next vertical asymptote. There's the point. So there we go. And at this spot right here, again, I'm not going past 2 pi, so I'm not going to graph the full shape of the graph. But again, this is one period. So this would be another period. This is half a period. This is another period over here, and again, that's just half a period. But yeah, with tangent and cotangent, and most textbooks do this as well, they don't really just graph one period because this is it. It's just this little sliver. So sometimes, and I'll do it for you guys too, they'll say graph more than one period. So in the exam, I only have 2 examples today to go through, but in the 2 examples, I'm going to have us graph 2 periods at least, so we can kind of see what's happening a little bit better. Okay, cotangent, I'm going to put over there. Look at the general shape of it. So let's let y be cotangent of x. So our vertical asymptotes are a little bit different, and it sucks that I erased the table, but it is what it is. I needed the board space. Okay, but for cotangent, our asymptotes are going to be at 0, pi, 2 pi. On this side, it'd be negative pi and negative 2 pi. Okay, so for cotangent, remember what I just said over here. The VAs are going to be where sine of x is 0. And sine of x is 0 is, well, at those locations, at those radian measures. Okay, so let's go ahead and draw where our cotangent is 0 at. So it's in between all these guys here, in between the VAs. And then we said because it's a reciprocal of tangent, it's just going to essentially just flip the graph in a way. It's going to be reflecting it. You can treat it like that. So it's going to be getting close to the y-axis without touching it, and then gets close to this asymptote and doesn't touch it. Now, just like tangent, this is one cycle. This is one period length. That's all you would graph. That would be it. But again, I'm going to graph a couple more periods so you can kind of see the full thing drawn out. So over here, I'll just repeat the pattern. Same thing on this side, and same thing on this side. Okay? So that's me drawing 1, 2, 3, 4 periods. I think, did I do 4 over here? I kind of did. 3, half, half, so I guess you could put those together and say 4 period lengths. Okay? All right. Any questions on what the graph looks like? So the only thing we got to do now is we'll put some facts about these graphs next, and then we'll jump into our 2 examples with it. We'll talk about what happens with a phase shift, and if there's a vertical shift and so forth, which really ain't that bad to work with those. Okay. Let's make a table. Y equals tangent of x, y equals cotangent of x. So we're going to list the domain, the range, period, where the VAs are located, and the symmetry. We did this with secant and cosecant. I'm just repeating it for these 2. Okay, so domain-wise, we can actually look at the graphs and see what the domain's going to be. Okay, but I'll put here. So our domain would be our x values, such that x cannot be pi over 2, or if you're adding some multiple of pi to it, it won't work. Okay, this is for all integers k. I think I told you before, your textbook uses n. When I was making this up myself, I just kept using k because k's are used pretty commonly for something like this. So nothing wrong with n's either. Okay, our range would be all real numbers. If you take a look at our 2 graphs, it increases and decreases without any bounds, which is good. Our period is going to be pi, so it only has a length of pi. You too? Okay. Next, VAs. Okay, so that corresponds with our domain. So it's going to be located anywhere where it's pi over 2, or again, adding some multiple of pi to it. Can you guys see that? Is this getting too light? Yeah? Okay. I'll try and press a little bit harder there just in case. And our symmetry is the origin. Meaning, if you remember origin symmetry, that's indicative of an odd function. I'll do this, because I did that with the secant and cosecant. So if it was a negative x value, it'll be a, negative y value. We can see that with the graph. If I were to take a point here and just flip the signs, I'd be down here. Okay. Now, for cotangent, let's do the same thing. So domain for this guy, all x values where x cannot be some multiple of pi, for all integers of k. All real numbers, again, for the range. Periods pi. Our VAs are just part of the domain here, so we're saying anywhere where x is some multiple of pi, we'll have a vertical asymptote. And this one also has origin symmetry, or it follows the same pattern as the other. Okay, I think we have fully exhausted all details with this graph, but it's good to have. It's good to know these details because we'll need it in the future to know like what the domains are and so forth when we talk about inverses. Okay, so before we do our first example, questions on what we've covered? Okay, let's start graphing. Let me just get rid of this guy over here. And when we graph, just like what you guys are going to practice for homework, I'm going to graph 2 periods. I'll still identify what 1 period looks like, but again, I'll just do 2 periods so we can see it a little bit more. Okay. So example. So we're going to graph f of x equals 2 tangent of pi x. Okay. Just a noise. I only have light blues left. I don't know if this is going to be better. Let's list some facts. I'm not going to list the amplitude only because, as we can tell, the amplitude's not really going to help us in this case. But because there's a number out in front, we do know it's going to be rising a lot sharply, right? Okay, it's going to rise a lot faster. So just keep that in mind. Period. Well, a period's just pi over my b value. So it's 1. Okay, that's pretty nice. Phase shift, there isn't any. Vertical shift, there isn't any. So we're all good with that stuff. We'll cover that in our last example. But here's the deal. A couple things. First, I want to know where the vertical asymptotes are. Because there's a pi there, they're moving. Okay? I know I'm pointing to cotangent, but you know what I mean. They're going to be shifting a little bit. So how do we find them? Well, first, we know that the asymptotes for tangent is going to be between pi over 2. That's where it's hitting. And then the negative pi over 2, the other direction. So what you're going to do is you're going to take whatever this is and put them between those 2 vertical asymptotes. Okay? So VAs. So you're going to take negative pi over 2 less than what's right here for the period, less than pi over 2. Okay? So what we're going to do is we're going to solve for x and see where these are shifting now. Because that's where they are originally. If you look back in your notes, the example we just did at the very beginning, you can see it. So what I would do is what? Divide everything by pi, right? Just to get rid of that, to get x by itself. So that would get rid of the pi's over here. So it would be negative a half less than x less than a half. Okay? So this is where our VAs are going to be located. Okay? Now let me ask you this. I'm going to put a line, vertical line here. This is going to be for 1 period length. So if I want to graph another period length, I want to figure out where those vertical asymptotes are going to be located, I'd have to add another full period next to it. Okay? So think about what's happening here. If I'm going from negative a half to a half, that's a period of 1, right? So my next set of VAs is going to start from a half and then add 1 to it. So it'll be what, 3 over 2 or 1 and a half, right? So this is for 1 period. But if I want to find another period length, I add 1 to my most recent. So there'd be a half less than x less than 3 over 2. Okay? Or if you want to put 1.5. If you want to do decimals, that's fine, but I think these are easy fractions. So this would be the VAs for my second period, which we are going to graph. Like I said, I want to try and graph at least 2 periods each time. So does that make sense? And what I'll do, let me put this in red. I got there by doing a half plus 1, which is my period length. Okay, and you would do that every single time. If you had to graph multiple periods, that's how you would find those. Okay, we only have one more thing to write down. I want to know, where's it hit the x-axis, right? And one thing we can tell is this. It hits the x-axis right in the middle of these two VAs, like the midpoint. If you remember, to find midpoint, you'd add these and take half, okay? So let's find the midpoints for both of these so we know where it hits the x-axis. So I'm going to take my VAs, so it'll be negative a half and a half. I'll add them and take half. That's how you find midpoint for anything. And this one works out really nice, almost like I planned it that way. You get 0. So at 0 is where this graph is going to have its midpoint and then rise above and below. Okay, let's find the midpoint for the second one. So we're going to have a half plus 3 over 2 divided by 2. Okay, and I could see that this would be 4 over 2, which is 2. Divided by 2 is 1. So at 1 on the x-axis is where we're going to draw our point where it hits the x-axis. Okay? So we're ready to graph it, but any questions on how I found this? You're going to repeat this for pretty much every graph. Okay? Find your period. Some people don't want to write that if there isn't anything. That's fine. Like I said, it's just how my brain's working. And then to find your VAs, what it is originally, which is this, whatever's here, put in. Solve it. These are my new VAs. That's one period. To find another period, just add the period to this guy, because that's where it starts for the next set. Add to this side. And then find your midpoints for each one by adding your two VAs and taking half. I'm going to use this whiteboard to graph because it makes more sense to keep these next to each other. So I'm not skipping a whole board to look at it. So here we go. I know they don't, again, the amplitude's not really going to matter. It depends. I mean, I put at least 2, so 2 to -2, but just to have some marks on the y-axis is fine. So what do I graph here? Because remember how we do increments with the other ones? I don't have to do it in this case. I know what the VAs are. I know where I'm hitting the x-axis. That's all I'm going to plot. So my first set of VAs are -1/2 and 1/2. So I'll put -1/2 and 1/2 here. The midpoint is 0, so that's where that goes. Okay? So let me go ahead and draw my vertical asymptotes. Just like that. And then we already know how tangent's going to work. Okay? It's going to get closer to this, not touching it, and same thing in the negative direction. And again, this is one cycle, or in other words, one full period. But just to get you used to graphing another cycle, another period, like how would you do that? Let's graph this part now. So -1/2, we already graphed it. We need 3 over 2, and we need a 1. So let's do that next. So 1 and 3 over 2. 3 over 2 is one of my VAs, so I'll put a nice vertical line, dotted one. There we go. So that 1 is where it's going to be hitting the axis at. And then again, we know what the shape looks like. We know what it's doing. It goes up to this point and down to this point. Okay. If you want, and let me just put this underneath this. So this is like another one cycle. This is one full period. If you want a little more accuracy, could you plot additional points? Yeah. So for instance, could you plot like, oh, I don't know, this is 1, that's 1.5, so no, 1.2? You can. You can plug it in there and see what it gives you. That's no big deal. But for right now, this is good for me. Okay. Questions? All right, so we just got cotangent. We'll do one example with cotangent. And this example, I'm going to do a phase shift and a vertical shift with it. So I'll show you how to work with those, which isn't that bad. here we go. Let's graph y equals cotangent x plus pi plus 1. Okay. So list some things. Again, I'm not going to list the amplitude because that's not going to really affect things. Period length is pi over whatever this is. There's a 1 there, so 1 over that's just pi. Okay, phase shift, yes there is. It'd be opposite of that, so negative pi. So my cotangent graph's going to shift left. And then my vertical shift is a 1, so we're going to go up 1. I will say vertical shifts are easy to maneuver when it comes to these guys. If you remember with the other 4 functions we did, we had like a dotted line where the x-axis would be. We don't have to do that here. Okay, next, just going through the list here. So let's look at where the vertical asymptotes are going to be. So for cotangent, the period length's pi, okay? But we're only going from 0 to pi itself, okay? That's where our values are. And then it starts repeating in that afterwards. So it's going to be 0 less than whatever's here, so x plus pi, and then less than pi itself. So just be careful. So cotangent is 0 to pi, and then tangent is negative pi over 2 to pi over 2. Okay, so that's the only huge thing you got to make sure you distinguish. The rest of the process is the same. Okay, it just depends on where the values repeat. So solve for x, I'll subtract pi to both sides. This is negative pi, less than x, less than 0. And again, this is 1 cycle, in other words, 1 full period. But just for our notes, we're going to graph 2 periods, so we get used to knowing like how to do that. So it's going to start here at pi, our next period. And I know my period length is pi itself, so if I'm adding pi to that, it's going to be 2 pi. So that works out nice. So this is another cycle, which is another full period. Okay? Yes?
What if it started at 0?
Oh, thank you. I was looking at this, not this. Appreciate that. Which would be pi. Thank you. Now, we got midpoints. So let's do the midpoints for this guy. So we'll take our 2 asymptotes, divide by 2. So negative pi over 2 is where we're going to be touching the x-axis. This almost seems easier than the increments at times. And on this side, 0 plus pi divided by 2. So that pi over 2 is where we're going to have that midpoint. Now here's what I'm going to do before I finish and then start graphing. We know that that's where it's hitting the x-axis. But because there's a vertical shift, all it's going to do is take that value and just move it up 1. That's it. So what I'm going to do here at the bottom, I'm going to put with the vertical shift, this point's not going to be at negative pi over 2, 0. It's going to be at negative pi over 2, 1. Okay? So again, I'm just taking that point and just moving it up by 1. And then over here, I'll do the same thing. So with the vertical shift, it's pi over 2, 1. Okay? Now, let's just say this was a plus 4. Okay, well then this just changed to 4s. You're just moving that point from the x-axis up 4. If it's negative, same pattern. You're just moving it down by that much. Okay? Alrighty, well, let's graph it. think it's this marker's last voyage. Its last problem in this world. Where we start at negative pi. And then the midpoint was negative pi over 2. And then 0 for that, so that's good. So our asymptotes are going to be at negative pi and 0, so that's already there. I'm not going to worry about drawing it. Okay. Now, again, because of the vertical scale of up 1, my point's going to be up here, not at the x-axis anymore. But the good news is it's still going to flex. It's still going to not reflect, but it's going to, well, there's a mathy word for it. It's not coming to mind. It's going to come to mind afterwards. Can't think of it right now. But we know that it typically does this. It's the opposite of tangent. But this is where it stops and it starts going in the other direction a little more sharply. So there we go. Okay. Let's now graph the second period. So let me I'll put here, this is one period length or one cycle. So to graph the other one, it's going to start at 0. The midpoint's pi over 2. Oh geez, come on. Survive. And pi. And let's see, the asymptote's here. And then the point would be pi over 2 once. It's up here. And then again, we know kind of like the pattern that's going to work with, which is this guy right there. So this is another one period length. Okay. That, my friends, can we do 2 for 2? Hey, another trick shot. Just like I planned. Okay, questions? Think we got it? Okay, that's it.